So a multiplication multiply by b, and then result is 50, and then a divided by 5, b result is 2, and then a modulus b and result is 0. So that's the, and then you can also combine the complex mathematical expressions to do the mathematical calculation. You can also do all the with the existing mathematical functions, or whatever it is, you can do also what you like to do. And then this was the only understanding, the basic understanding how the different type of operators. The most used all the operators, but most this is the mathematical calculation. You can do also the calculus calculation, differentiations, and all Fourier series calculations, all things is possible. Just you need to understand the operator, and you can write down the proper expression of your combinations, all the operators, even though all the functions from the existing math libraries, even though you can use it math libraries, and then even though it works automatically. So existing, there is many as math. You can show also the random functions. Random function, you can put it also the random values, and then so on and so forth. So this is those the things that I see, the operators. You can combine the one functions to the another functions, do the math complex calculations, and then so on and so forth. So if I run the program code, that operators, very simple operators, the plus, see the plus 15, 5, 10 minus 10 plus 5, 10 plus 5, 15, 10 minus 5, result 5, 10 multiply 5, 15, 2, difference between the two, the divided by 2, and then the modulus is 5, and then random value is this 1. So this is a very simple understanding of the mathematical operator: plus, minus, multiplication, division, and modulus. And even though you can write down the complex expression of the mathematical calculations. And shifting operators, how it's look like. Let's have a different shifting operators. Let's see how it works in practice. So shifting operators, you see the operators like I have like the C less than equal, the left shifting operators. Yes, left shifting operator examples. So 10 left shift double less than, and then 2, that means everything you have you have a value, and then multiply by the existing first value, you put it here, and then based power 2 based on the 2 base 2, and then you power. That means you see the 10 multiplied 2 power 2, 2 power 3, 2 power 2 again, and 2 power 4. So everything is the base based on the 2 based calculations. This is left shifting operators. If you do the right shifting operators, is simply the difference between the right shifting operators, like simply the divided. So it was the multiple for the left shifting operator, and the right shifting operator is only for the dividing the u value with 2 base power. And you have see the positive number, and then you have a left shifting operators, and then 3 greater than operators, and then so on so forth. If you have the negative value, and you can get the idea what's the result for this one. So let's have a run this. So, and then you see the left shifting operators divided by 2, 82, and 2 and 5 left shifting operators. And then you see the 2 and 5, 5 and minus 5. This here is a left shifting minus value, the multiplication value or division value, and then you have this one, so minus 5. This value, this is a real value of the third greater than signs with minus value. So left shifting operator, we got the idea. So it has two options. It has a left shift operators, divide, meaning that the value and the multiply and 2 base power, and the right shift means that divided by the value divided by the 2 base powers. And then there's a left shifting and right shifting with the 3 greater than signs, and then it has different base calculations based on the positive value and based on the negative value. It has completely different pictures of that one. So just you can close look at that one. So this is the most important one, the logical and then bitwise operators. That's I already said. The logical and bitwise operator, we need to be really close look these operators. So let's do this way. The logical and bitwise operators. So that means you have set it A, B, and C. A is 10, B is the 5, and C is the 20. So logical operators, meaning if you have the more conditions, like this is the one of the conditions, the logical condition. The meaning of the logical and conditions, it does not check the second conditions if the first condition is false. If only check the second condition if the first condition is true. This is the logical operator, how the AND operator works. And the bitwise operator, the AND operator, it only checks the both condition. That means condition 1 and condition 2 is always checked for the bitwise operators, but the logical operator, logical AND operator, it only check the second condition if the first condition second condition if the first condition is not is false. That means if the second conditions only condition is only if the first condition is true, then it goes to the second conditions. For the logical operator, bitwise operator, sorry, bitwise is checking the both sides. If you see the A less than B and sign, the logical and then A less than C, that's true. The result is true. Yes, it is true, false, and then true, and the up to result is false. So in the end, then bitwise operator, you see A greater than, that's true, that's false, that's true, and then there is a less than C, and this is also true, and the result is false. So by then you have see the bitwise operator. Again, example, A less than B, and then logical operators A plus plus and false false, result is false, and then just printing the real value, and so on so forth. So you see the effect how the logical operators and then logical AND operators, and then logical bitwise operator and operators. That means it's the most important, you need to be remember, logical AND operator does not check the second condition if the first condition is false. It's check the second condition only if the first one is true. For the bitwise operators and AND operators only check the both condition, whether the first condition is true or false. This doesn't matter. So for the logical and then operator or conditions, how it works, you see the logical or operators is here, the line number 72 is true. Logical or operator does not check that second conditions is true if it check the second condition only if the first one is false. That means that's true. And then for the bitwise operator and or conditions, operators check always the both side, the two first conditions, and true and false. Doesn't matter what's the first condition, true or false. You see the effect, this one. So A greater than B, and then or A less than C, the result is true or true, and output is true. And you see the A greater than B, and or the bitwise operator or A less than C, and result is true, and the true or true result output is the true, and so on so forth. So that's the impact you need to remember, you need to understand for the logical AND operators and logical versus the bitwise AND operator, and logical OR operators and bitwise OR operators. This is two different operators. You need to be clearly picture it and to clearly understand it, how it works. That means one case if it's only check the logical operator, the first condition based on the first condition is the second condition